All right, the print method is going to print out our binary search tree. And we're going to use a typical approach here. We have our private static helper method that takes a node as a parameter. This is what we'll recurse in. This is the public method, which, again, we've been writing a lot of this. So just like we've been writing, this is super simple. We're just going to call the private static helper method. So I'm going to be extra explicit and do class name dot print. And we'll pass along the root. And then I'm going to add a system.out.println here, just because it's going to format it nice with an extra line at the end. There's a lot of ways we could print our tree. We're going to write some code to print it in one way. And tomorrow we're going to explore, like we're going to give this a name and we're going to look at this in more detail. But for now, we're just going to say terminating condition. We're doing recursion. The simplest tree to print is the tree where the node is what? Null. We have an empty subtree. So if parent equals null, return. We don't print anything. Otherwise, we only have to take one small step toward a solution, and then we're going to recurse. This is a more complicated recursive method because we're going to recurse twice. We're going to first say print, and we're going to say parent.left. We're going to tell the left child to print its subtree in its entirety. When that finishes, the small step we're taking is we're going to print this node's data. And I'm going to add a little space there so that, print line, let's just do print. I think that's better. So it'll all be like in one line. Then we're going to tell the right child to print its entire subtree. So this highlighted line of code is the small step we're taking toward a solution. We're going to print this node's data. And the way we push off the rest of the problem to someone else is we tell the left child to print its subtree. We don't care how this happens as long as the whole subtree is printed by the time this returns. Then we ask the right child to print its subtree. Again, we don't care how that's done as long as the whole thing is printed by the time this returns. And then we'll return. That's like all it takes, which is kind of cool. If you click on tree tester, here's a binary search tree where I'm adding a bunch of letters and removing some, and then I'm printing it out at the end. So you can click on run here and make sure that the output that's printed matches the expected output, which it doesn't. Interesting. Huh. Fascinating. Well, we have a mystery to solve for tomorrow, I guess. All right. If any of you